Next we have addition and subtraction with rational expressions. The first kind that we want to do addition or subtraction with have the same denominator. So you can see I have this rational expression, subtract this rational expression, and the two denominators are the same. This problem will work exactly the same as subtraction with regular fractions in that we'll simply combine the numerators and put the result over that common denominator. So there's my y minus 1, that's the common denominator, and I had y squared minus 1 for the numerator. Next we reduce to lowest terms if we can, y plus 1 times y minus 1 when I factor the numerator, all divided by y minus 1. Divide out this common factor y minus 1 from the numerator and denominator. What's left is y plus 1. So y plus 1 is the difference of these two rational expressions right here. So the only way we can combine rational expressions with addition or subtraction is if they have the exact same denominator. Our next problem is one that starts out with different denominators. I want to add x over x plus 1 and 3/4. So I look at these two expressions right here and I want to build a least common denominator from the two denominators. So the least common denominator has to have a factor of x plus 1 so that this denominator divides it, and then it needs a factor of 4 so that this denominator divides it. So I'll put in a factor of 4. That's the least common denominator. Now to change this fraction to a fraction with this denominator, I multiply by the number 1 in the form x plus 1 over x plus 1. So multiplying by this won't change the value of this fraction right here, but it will give it this least common denominator. This fraction here has a denominator of x plus 1. I want it to have 4 times x plus 1, so I multiply it by 4 over 4. Now, here's the result of doing this. This becomes the fraction 4x over 4 times x plus 1, and this becomes the fraction 3 times the quantity x plus 1 over 4 times x plus 1. It's the same addition problem that I had previously, it's just that now the two denominators are exactly the same. That means that I can combine the numerators and put the result over that least common denominator. So I'll do that. This is 4x plus, let's multiply this out, 3x plus 3, all divided by 4 times x plus 1. Now 4x plus 3x is 7x plus 3, all divided by, I can multiply that out or leave it the way it is. Let's just leave it the way it is, 4x plus 1. Now the reason that I left this denominator in factored form is if the next step would be to reduce this to lowest terms if the numerator and denominator had any factors in common. They don't, but so I'm just going to leave the problem this way. Generally our polynomials when they're in factored form are easier for us to work with. So that in any case, that's a look at adding a couple of rational expressions that don't have the same denominator. Let's try a little more complicated problem. 8 over x squared minus 16, this, subtract this. Well, let's start by changing subtraction to addition of the opposite. I'll just take care of that right now. Next, I'm going to rewrite these two rational expressions with their denominators in factored form. So I factor the first denominator, x plus 4, x minus 4. It's 8 over that. And then I'm going to have plus minus 7 over x minus 4, x plus 3, when I factor this denominator completely. Now, I'm going to build a least common denominator from the factors of these two denominators. For this denominator to divide it evenly, I need factors of x plus 4 and x minus 4. So I'll put those in. X plus 4 times x minus 4. Now I know that this denominator will divide the least common denominator. For this denominator to divide the least common denominator, I need a factor of x minus 4. I have one. I need a factor of x plus 3. I don't have one, so I'll write that factor down. So here's my least common denominator. I want this fraction to have this least common denominator. Here's the factors that I have in its denominator. These are the factors I want. So I multiply this by x plus 3 over x plus 3. I look at this denominator. I want it to have these factors. It has these two right here. What it doesn't have is the factor x plus 4. So I'll multiply it by x plus 4 over x plus 4. So you see, I've factored my denominators right here, built a least common denominator from those factors. then I look at the factors I have in each of my denominators and the factors I want. Whatever they don't have, I multiply by the number 1 in that form. So multiplying here by the number 1 won't change the value of this, and multiplying over here by the number 1 won't change the value of this. But I do end up with two fractions with the same denominators. So to finish this problem then, let's multiply 8 times x plus 3 and get 8x plus 24. To that I want to add negative 7 times x plus 4, which is negative 7x minus 28. And that's all over the least common denominator, x plus 4, x minus 4, times x plus 3. So that's a couple of steps at the same time right here, where I've multiplied out these two products right here and then added them up in the numerator, put all that over the least common denominator. One last thing to do, simplify that numerator and then see if I can't reduce to lowest terms. So let's see, 8x minus 7x is x, 24 subtract 28 is minus 4. And that's all over x plus 4, x minus 4, and x plus 3. So I have a factor of x minus 4 common to the numerator and denominator. I divide it out. What's left in the numerator when I divide out x minus 4 is the number 1. In the denominator, I have x plus 4 times x plus 3. So there is what I get when I add or subtract these original two rational expressions. You may want to play this problem over a couple of more times so that you see this is about as difficult as it gets with adding rational expressions.